Hi everyone, I am Ganga Devi from SFR College. Through this video, we are going to see an overview about the data structures. So in this video, we are going to see what's the data and why we are going to structure it and what are the different types of data structures available, and we are going to see some applications of data structure. So what's the data? So data is nothing but an information that is usually formatted in a manner for some purpose. We are going to use the data for some purpose. So if you are going to arrange the data in particular structure, then it will be easy for us to read or understand the data, not only by us but also by the machines. So we are in need of data structures. So after we are structuring the data, it will be easy for us to store them and for performing some operations. It can be accessed and used efficiently. And also it's easy for us to manage the large amounts of data and performing operations like searching, sorting, insertion and deletion in an efficient manner. So let me see the types of data structure available. So in data structure there are two types, linear and non-linear. Linear data structures are array, stack, graph and linked list. So in non-linear data structure, graph and tree are the most important ones. So in this video, we are going to concentrate on the linear data structures. So what is linear data structure? So here the elements are arranged in a sequence manner, one after the another. It's very easy for us to implement, but the complexity of the program is getting increased. So in case of non-linear data structure, it is not following any sequence. It is arranged in a hierarchical manner, one by one. But here these elements are getting connected to one another. Okay. So in linear data structure, let me see one after the other. So what is an array? So array is nothing but a data structure. It's used to arrange the available data in a continuous manner. So in memory we are going to allocate continuous memory for the data. So what's the purpose? It's easy for us to calculate the data. It's easy for us to access the data. If you want to access any particular element of the array, then you can use a simple formula. So base address, that is the starting address of the data plus the data type size into the index we want to access. So it's easy for us to access the particular information. So it's easy for us to manipulate. But the problem is, if you want to insert or delete a data from array, then it becomes a very complex, tedious job. Why? So if you are using 5 cross 5 elements in an array, then no problem. But if you are going to use 50,000 and 1 lakh of data in an array, if you want to structure that particular large amount of data in an array, then it's not an easy manner. So next data structure available for us is the stack. So in the stack, the elements are arranged such that the elements can be accessed from only one end of the stack, that is from the top. So the elements can be inserted or deleted from that top position only. So I have given some example diagrams. So one is the stack of plates. If you want to access the plate, then you can only get the topmost plate. You can't get the plate from the base side, right? Like that, a handful of bangles. So just imagine, so if you are going to put one by one bangles in your hand, then the last bangle you are inserted is the first bangle you can get off from your hand. That's why it's called as last in, first out. Okay, so here the elements 2, 5, 6 and 78 are getting inserted into the stack. The top element is pointed to the 78, that is the index position 3. If you want to delete an element from the stack, then 78 is only going to getting deleted at the first stage. So next data structure is the queue data structure. We all follow queue in our real life in many situations. Example, in ticket counters, everyone is standing in a queue to get a ticket. The first one come to that counter will get the first ticket, isn't it? So here the persons are getting inserted from the back side of the queue, and after they are finishing their work, they will get out from that queue from the front side, right? So that's why in queue the data can be inserted or deleted from two ends. That is, insertion only happen at the back side, that is rear side, and deletion will be happen only at the front side of the data structure. Okay, so this is here the first one coming into the queue will first getting served. So before first in, first out. So the next data structure is linked list. So here the elements are not going to occupy the continuous memory location in the RAM memory. But here we have that is physically they are not in a continuous manner, but we can get them attached to one another through the pointer values. So here we can we can see the example for linked list as the train. So the compartments that are getting connected to one another through that particular connector, right? So likewise here each and every data should be getting connected to one another. For that purpose here the data is called as, that is we are having a node here, node structure here. The node contains two fields. Okay, one is the data field and another one is the reference field. That particular reference field is pointing to the next node. So likewise it's getting, so A is pointing to B, B is pointing to C, C is pointing to D. It goes on like that. The last node, that is D, it's not going to point to anyone else. That's why it's pointed as null. But here if it's in, just imagine in a larger memory area, if you are going to put these nodes in any memory address, you can place it anywhere. But if you are getting the A's address, then you will surely get the B's address. From there you will go to C and from there you will go to D. Okay, so this is the linked list concept. Here the main pointer value we are going to use is the head pointer. Head pointer is nothing but the pointer value that is pointed to the first node of the linked list. Okay, so these are the very important data structures that are available in linear data structure type. So the operations that are performed by stack are the pushing, popping operation, that is insertion and deletion, and we can get the topmost value. As well as in queue also we are having insertion and deletion operation. Apart from that we are having the front and rear value. We can get the front and rear value. So in linked list also we are getting the same insertion and deletion operation. So apart from that we can search the whole data in the linked list and we can display the content in the linked list one by one. Okay, so the applications we are going to use in these data structures. So stack is very much used in mainly used in the function calls and recursive function calls of the system. Okay, let me see that in the next slide. Then the remaining applications are, if you are going to do undo or redo operations in some applications like Paint, Photoshop, etc. For that purpose we are going to use the stack data structure only. The expression evaluation is using stack and also browsing history is also using this stack. So these things are having only one end. You can imagine that thing. In queue, so applications of queue are the task scheduling. The first allotted task will first get the CPU timing, right? The resource allocation. The first allotted process will get the resource, buffering, event handling and printer queue. Okay, these are following the queue data structure concept. So for linked list, the applications are the image viewer. If in our program in gallery we are going to scroll through the photos of ours, so we can go both in front and from an image we can go to front as well as to the back, right? So that is image viewer. Here it follows linked list concept as well as our music player and navigation systems used in Google and task scheduling. These things are using linked list concept. Okay, let me see the two applications of stack in expanded manner. So first one is the function call. So in every programming languages we are calling some functions, right? So whenever we are calling a function from the main function, we know that we are having a program counter variable which is pointing to the current executing statement's address, isn't it? So here 100 is the current execution address. So on executing 100, that particular 100 is going to execute a function, right? Function is available at the location 2000. So here our system is generating a stack frame. So that stack frame is containing all the details like the local variables values and the return address after finishing the function where we have to return that return address everything. That stack frame is pushed into the stack. Okay. After that the function is executed from the address 2000. After finishing the execution, the stack frame is again popped up, and from that stack frame we are getting the returning address, that is 104. That should be occupied by the program counter. So our evaluation is getting that is our program execution is getting processed as earlier. Okay. So as like the previous steps, right. So this is the usage of stack in function call. So then second application is we are going to use the stack for evaluating the expressions. So in our system, for example, consider the example that is postfix expression 25 plus 4 plus. Here if you want to evaluate this expression, stack will be very useful. Here whenever you are seeing any operand, then push it into the stack. Whenever you are getting any operator, then pop the operands from the stack and do the operation and push the result back. This is the concept, right. So 2 is an operand, so we are pushing it into the stack. 5 is an operand, we are pushing it. After getting plus, we have to pop out 2 and 5 and we have to add it and push the result 7 into the stack. After getting 4, we have to push it into the stack. After again getting plus, we have to take 7 and 4 and we have to add it. So the result 11 will be pushed back into the stack. So these are the applications of stack. So finally, my conclusion part is no data structure will be best at every situation. So depending upon our problem, we have to decide which data structure will be very useful. Okay. So for any problem, if you want to solve any problem, then first you have to analyze the problem, then you have to we have to check the performance goals we have to determine, and after that the solution can be provided by the selection of the data structure. So that should be done by us only. Okay. So thank you for watching.